to our next session in the Everything But the Engine webinar series, where we take a deeper look into the components that are driving innovation and performance across Cummins. I'm joined here with Gabe Roberts, Director of Product Development for Valvetrain Products. Gabe, would you like to tell us a little bit about yourself and kind of what you do here?
Sure. Hi, everybody. My name is Gabe Roberts. I am the Director of Product Development at Cummins Valvetrain Technology. I've been here 15 years, which includes 12 years at Jacobs before we were purchased, and the last 3 years as part of Cummins.
That's great. Thank you so much for being with us today. So you were with Jacobs before they joined the Cummins family, right?
Yes.
What was that like? Is your background through Jacobs and into this Cummins period?
Sure. It was very fun. It was a very small company. Jacobs was a very small entity, all on its own. Now that we're bought by Cummins, it's a much larger company. The good part about that is you get to see a lot more about how the engine is made, about the limitations of the engines, the capability of the engines, and now we can work with the engine business to make sure we have an optimized product.
That's great. Absolutely. I love that. I love that history. I love that perspective of how you've brought that back to the Cummins organization. Speaking of engines, there's quite a bit around us right now. So where are we right now? Tell me a bit about this area.
We're in Bloomfield, Connecticut. This is where our headquarters is based. This is where Jacobs has had manufacturing. We also have our engineering center where we do all of our core engineering and some applications engineering. We make all of our product for a US and some of our European customers. And we are in the engineering engine lab. This is where we do all of our validation testing for our engines and our products.
Great. Love that. So this conversation today is going to be a little bit about the latest technology within the Valvetrain products. But before we actually jump into that latest technology, why don't we look a little bit about the history we have here, right? We have some very interesting pieces of history in front of us.
Yes.
So tell me a little bit about this right over here.
All right. That is a very early Clessy Cummins prototype brake. We believe it's serial number 2 for an engine model that I don't even know the history of. Clessy started with us 70 years ago. The invention of the technology was from Clessy Cummins. He then took that technology to Cummins, and Cummins turned him down originally. He then took it to Jacobs Manufacturing, who made Jacobs Chuck. Jacobs says, yes, I'd like to invest in that. And then we started Jacobs Vehicle Systems. Then, coming full circle, 2022, Cummins acquired Jacobs. It did feel like we were coming home. We started with Clessy. We worked through many years, over 60 years, working on Cummins products. And then we came back home, and now we're back with where we started.
Wow. So do you think Clessy actually made this piece right here?
I think so. I've seen pictures with him on a lathe, cutting parts himself on his tool bench at the Heritage Center in Columbus. Yes.
That's just, I feel like this should be in a museum right here.
Yes.
It is just a piece of history.
Yeah.
Right? So tell us about this piece that we have right here in between us.
Well, actually, this is a progression of the technology. So what I wanted to show was this is the early prototype. This was an early bolt-on slab brake is what we call it. This is where it all started. So it made a it's a jump in technology, but not a very significant jump. This is a more modern slab brake. This bolts in the top of the engine. It doesn't disturb the base valve train at all. You bolt it in. It does its job to do engine braking, and then you can take it out. It is a bolt-on brake. Very similar to this one, but a more modern configuration of that. Yep.
Interesting. So when was this kind of introduced?
This is more like the late 80s and 90s.
Gotcha.
Right? As we were still at that point, we were also an aftermarket solution. So the OEM would deliver the engine, the truck driver, the operator of the vehicle would then order the engine brake and install it themselves. It was an aftermarket option at that point.
Great. And what are these pieces over here?
All right. So in the mid-90s, we made a pretty significant transition from a bolt-on aftermarket solution to an integrated OEM solution. So this engine brake right here was the first dedicated cam engine brake. Now a rocker brake. This is for the ISX 15 back then when it came out. And this allows all the engine braking performance of this, but now integrated into the Valvetrain The rocker shaft, it's under the valve cover. The rocker shaft, the cam lobe are all integrated so that you get the most power out of it, the most efficiency out of it. So, and also because it's smaller, it's less cost with the same amount of performance.
After looking at the history that we have here, where are we at today?
Okay, so after the start of the integrated brake here, we then continued to expand on that in the early 2000s. We now came up with a number of different versions. So again, various forms of dedicated cam engine brakes came out. Different styles, different configurations, for different packages. We also have what emerged is what we call the integrated rocker brake technology. This is a lost motion rocker arm that does braking and the main event together. This is now becoming quite common on medium duty engines. It's lower cost because one rocker arm does two jobs. It does braking and it does main event. One cam lobe does two jobs. It does braking and it does main event. So integrated rocker brake, otherwise known as IRB, we term that. And then also we developed the launch of bridge brake technology. Yes, this entire slab here, the function of this can fit into the crosshead.
Wow.
So this can do all the engine braking and has more performance than this at a very small fraction of the price. And this is, of course, very easy to integrate into small and medium duty engines. Still lost motion technology. But more recently, after the acquisition, emerged what I would say is the next generation of technology. This is the Power Progress award-winning X15 next generation engine brake. What you'll notice on here is this capsule up here. So this is called a wedge capsule. The brake has gone from a traditionally hydraulic brake system. This uses engine oil, and all these use an engine oil to create a high pressure circuit that actuates the valve and engine braking. Now, instead of using hydraulic high pressure oil, we use a mechanical system to actuate the engine valve. So in here is a series of wedges that lock and unlock depending upon the actuation of the brake. They're normally unlocked, and when oil comes into the brake, it mechanically locks them, allowing you to actuate the valve using the engine brake valve using the engine brake cam. And the benefit of that is it's extremely fast. The wedge technology is extremely fast versus the hydraulic system.
Great. Let's take a minute and take a look at some of these other engines. So now we moved from history to one of the most advanced engines in our lineup, the X15. Gabe, can you tell us a little bit about what's interesting about this engine here?
Yes, it's a very exciting engine. This is the flagship for Cummins, the X15 engine. It is a new engine, essentially from the ground up, and the Valvetrain is very special on this engine. Specifically, with the new engine, Cummins has moved to a double overhead camshaft architecture. That allows for two camshafts, one on the intake and then one on the exhaust. What that does is allows for more efficiency in the cylinder head design, allows for more port design efficiency so that the airflow through the engine is done better so that you can get more performance out of it. Better fuel economy, lower emissions, better overall performance.
Great. And how did you, get to this point where this has been some of those breakthroughs?
Well, the technology that we used on this engine has actually been in development for over 15 years. It started with our high power density brake system. We had to devise a collapsing mechanism that would allow us to deactivate the main exhaust so that we could achieve two compression release events for a high power density brake system. From there grew the cylinder deactivation technology that we've since developed. We've now taken that mature cylinder deactivation technology and used it on this engine because it's very fast and very reliable.
What are we looking at here? Where are some of our highlights within this product, this engine?
Sure, let me walk you through how the engine brake works on the X15. This is the exhaust side. This is the exhaust side rocker shaft and camshaft. This is the intake side. You will see two rockers per cylinder. You will see the main event rocker, and then you will see the brake rocker. The brake rocker has the wedge capsule that we talked about earlier in there. You will notice that the main exhaust rocker touches the brake rocker. That's because this engine has no crosshead on the exhaust side. It's done that so that the engine business can have more port efficiency by having the valves close to the injector. To accommodate that, we developed a technology called the transfer thumb that allows the main event rocker to push on the brake rocker so both exhaust valves can actuate in positive power. Now, when you want to go into braking, what happens? This brake capsule, this brake rocker, and this wedge capsule get energized. The engine computer activates the solenoid, which allows oil to come up from the engine through the rocker shaft into the wedge capsule and then lock the wedges in the lock position. Once that happens, the dedicated brake cam lobe is able to transfer lift from the cam through the rocker arm to just the brake valve here. So a mechanical wedge capsule system, solenoid activated with engine oil to do single valve braking.
You said you've been working on this for 15 years to get to these kind of points. Has since joining Cummins, has like being a part of the wider organization and working with a broader team helped you move any of these parts forward?
Yes, well, the most important part of now working directly in the Cummins organization is that we get a lot more access to information. For example, we can understand challenges that the engine business has, and then we can help solve them because we have more intimate knowledge of them. For example, when the engine business wanted to have no crosshead for port design, they came to us to design a valve train that would accommodate no crosshead. So we did that. So it allows them to maintain the most efficiency without compromise for the engine braking system. And having that communication has been fantastic. The same happens with our sister companies, turbos and fuel systems. So in addition to Valvetrain, we have Cummins Turbo Technologies, we have Cummins Fuel Systems, two systems that we work with on every engine that we develop. But now we've been able to engage more with them. So for example, we found a limitation with the turbo in the engine braking performance. We then worked with the turbos team to overcome that and still have the most braking power possible without putting any risk to the durability of the turbo. And the same with the fuel systems.
Can you explain that wedge capsule technology and why it's important?
Okay, I'm glad you asked. All right, one of the reasons that we moved to the wedge capsule technology on most of the new engines is because of speed, right? More commonly these days, OEMs are using the engine brake for shifting. It used to be an old trick that the old time truck drivers used to do jake shifting. They would enable a shift using the engine brake when going uphill to reduce the amount of time that the engine and transmission are separated while it's trying to synchronize gears. You apply the engine brake, it changes the engine RPM quicker, enabling a faster shift. So now, the quicker your engine brake is, the quicker you can do an engine brake enabled shift, and the more fuel you save going uphill. The response time of a mechanical wedge capsule brake system is about half of what all the other hydraulic brakes are out there. So this is a very fast acting wedge capsule mechanical brake designed to enable engine brake assisted shifting.
Thank you so much for walking us through all of this. We're going to go take a look at the B7.2 next. Gabe, can you tell us a little bit about this engine and what's so special about it?
Sure. The B platform is a very important platform for Cummins. On the new engine, the B7.2, we've moved to a double overhead cam architecture, just like the X15. However, the architecture is a little bit different. Specifically, it is a Type 2 arrangement. So a Type 3 arrangement, like on the X15, is where the camshaft pushes up on the rocker arm to open the valve. Now, on this configuration and some of the other engines, it's a Type 2 valve train. That means the camshaft is on top and it pushes down on the rocker to open the valve. There's some efficiencies when it comes to cylinder head design and packaging, moving to a Type 2 from a Type 3 valve train. As you can see, there's a lot in here. 2 camshafts, all the injectors. There are no crossheads on the intake side. There is a Y rocker. And on the exhaust side, there is a dedicated cam engine brake. It's very hard to see inside a Type 2 valve train, so I brought a show model for us to look at. But you can see this is the way the cylinders are arranged. The exhaust valves right here, there's 2 of them. There's a crosshead that goes between them. We have a main event rocker here, push down on the camshaft to open both exhaust valves for main event, exhaust. And then you have the smallest dedicated cam engine brake that we've ever made packaged right here. What happens when the solenoid activates the engine brake, oil comes in through the cylinder head, up through the rocker shaft, extends a hydraulic piston that activates the engine brake so you can achieve your compression release events. It's a standard 4-stroke engine brake packaged into a Type 2 overhead. The first time that's been done as well.
Thank you so much, Gabe. We're going to transition now over to the B6.7 octane. Gabe, can you tell us what's special about this engine?
All right. First and foremost is a gasoline engine. This is Cummins' first gasoline production engine. And Cummins' motivation to do this is the goal is to have the same power ratings, the same torque ratings as a medium-duty diesel engine, but without the emissions requirements of a diesel engine, right? So, well, how does Cummins do a gas engine? They do it like a diesel engine. They give it the robustness, the durability that's needed for that. But from our standpoint, there's really 3 technologies that we want to go through on this engine. But first, let me talk about the Valvetrain. Again, like the other engines, Cummins has moved to a double overhead cam architecture. You have the intake camshaft, you have the exhaust camshaft. As I said before, having a double overhead camshaft allows a lot of efficiencies in cylinder head design, port design, cooling, and efficiency. All makes it work better than a single overhead camshaft. Like the B7.2, this is a Type 2 Valvetrain. The camshaft is over the rocker arms and pushes down on the rocker arms to open the valves. So out of the 3 technologies, I'd like to talk to you about the phasers first, right? This is a really great technology, and now Valvetrain is able to offer phasers outside of the engine business to other customers, but bringing phasers into commercial vehicle engines has been very hard. Just like cylinder deactivation technology, you can't take an automotive solution, bring it into heavy duty, where it needs to last 1 million miles, it needs to have perfect performance, it needs to handle higher loads and more difficult environments. It's not that easy. So
right.
We've now taken the phaser technology from automotive and moved it into heavy duty and created a heavy duty commercial vehicle type phasing technology. So it's great because you can use on the exhaust side, you use the phaser to shift your exhaust valve lift so you can do thermal management. You can manage your after treatment system, your catalyst, and keep it up to temperature. You can also vary the valve timing on intake for CO2 and fuel economy improvement. So 2 great technologies. The phaser is a great technology to have on the engine for overall engine efficiency. Now, because this is a Type 2 Valvetrain, it's best that I take the camshaft out so we can actually see the rocker arms. So, excuse me. The second technology I'd like to talk to you about is, of course, the engine brake. Once again, there is no crosshead, there's no bridge in here between the exhaust valves. Instead, like the X15, we use the transfer thumb technology. So this is the main event rocker. These are the braking rockers here, and we use this transfer thumb to enable both exhaust valve lift when it's in main event. Then, when the solenoids, the engine brake solenoids command the engine brake on, the oil comes through the cylinder head, up into the pedestal, through the rocker shaft, and then locks the wedge capsule. Because it's hard to see in the engine, I brought up a wedge capsule for us to look at. This is the octane wedge capsule. It's much smaller than the other engines, of course, because of load on the system. But this is the system that is normally unlocked, and then when oil is provided to it, the wedges pop out, and then the capsule locked, and then you get transfer of lift from the brake cam through the rocker arm to open the exhaust valve. The third technology I want to mention today is hydraulic lash adjusters. It's not common in heavy duty to have hydraulic lash adjusters, but moving from automotive into heavy duty, we were able to address the durability of the hydraulic lash adjusters. This engine has them. It does many good things. Number 1, it reduces the NVH, noise, vibration, and harshness. So this engine is much quieter. You don't get the diesel rattle that you would normally hear. It's a gasoline engine. Number 2, it eliminates the need to set lash on the manufacturing line and in service. So now imagine you don't have to service this engine at all. You don't have to get in, you don't have to set lash after it's delivered to you. What I like about it is it's able to maintain the ideal valve lash throughout the life of the engine. So as you have different thermal growth, or the seats wear, or the valves wear, the valve lift tends to change. Now with the hydraulic lash adjusters, you can keep the valve lift ideal through the life of the engine, which makes the whole engine happy, the after treatment system happy as well. Great technology, I'm glad it's on the engine.
So, seeing as this is the first time your engine brake has been on a gasoline-powered engine, Is your technology compatible with other fuels as well?
Yes, natural gas, hydrogen, propane, other fuels, absolutely. The technology works on all of the different fuels, but each fuel you have to take into consideration certain design elements. For example, you have to be very careful of water byproducts in hydrogen combustion, natural gas combustion. Make sure your technology will not rust or corrode when exposed to water-based byproducts at that point. But yes, the technology, all our technology is compatible with different fuels.
When you run all of these technologies together, what's that overall combined impact?
Oh, okay. Well, it's been a lot of fun to use the phasers with the braking system. First time on this engine that my team has been able to do that. We can really optimize the performance of the engine brake. We can stay within limits. We can produce more power at lower RPM, all by using the phaser in combination with the engine brake. So throughout the RPM range, different applications, we can really customize the performance. It gives us another knob to tune the engine brake performance on the engine. It's been a very fun tool to work with.
Finally, we're over at the X10 engine. Gabe, it provided a little bit of a challenge on the Valvetrain side, right? Can you tell us a little bit about that?
Yes, this engine has a lot of jobs. It has to replace the L9 and it has to replace the X12. Two very important engines. It needs to have the fuel economy of the L9. It needs to have the power of the X12. It needs to have the engine braking performance even exceeding that of the X12. So yes, this engine has been a significant challenge. Just like the other engines, it has a double overhead cam architecture. You can see it has the intake camshaft over here and the exhaust camshaft over here. Again, allowing for port efficiency and cylinder head efficiency in the design. This one also has a Type 2 configuration. That means the camshaft is on top of the rockers, pushing down to open the rockers. The main difference on this engine versus the other one is it has our high power density braking system. That allows us to achieve much more braking power than your conventional 4-stroke engine brake. Otherwise known as a 2-stroke engine brake or 1.5-stroke engine brake, it allows you to achieve 2 compression release events per cam rotation instead of the conventional 1 compression release event. I brought a cylinder set for us to look at, and you'll notice it has 2 wedge capsules in it, right? Instead of 1, like the octane engine in the B7.2 and the X15. It has a main event capsule and it has a brake capsule. The main event capsule is normally locked, allowing the main event exhaust lift to be transferred to the valve. This braking one though, when you energize the brake, the solenoid and the oil coming to the hardware does 2 things. It locks the braking capsule and it unlocks the main event capsule. This is a cylinder deactivation capsule. By deactivating the exhaust side, it allows us to build cylinder pressure on the compression release event and also during the exhaust event. So we can achieve 2 compression release events, get much more brake power than a conventional system, all with 1 set of hardware. And we do that through the 2 capsule system.
So in terms of performance, how does this compare to others in the industry?
Okay, so because it's the high power density brake system, it allows us to achieve so much more brake power. This engine, when it launches, will be the highest specific power engine brake system in the world. Specific power is your total power divided by your displacement. The X15 will be the highest total power braking system. This will be the highest specific power braking system. Now, importantly, one of the reasons we're able to do that is through collaborations with our sister company, Cummins Fuel Systems. This system, the high power density system, puts a lot of heat, a lot of enthalpy through the exhaust system and the injector. So working with fuel systems, we came up with a new injector tip temperature limit and system that allows our braking system to hit higher temperatures, therefore not limiting our performance. Something we were able to do because we're within the Cummins organization now.
So Gabe, we've covered a lot today. We've looked at a few different engines here. We've learned a little bit about the history. If there was one big takeaway, what would that be?
I say it has to be like synergies, right? Now that we're within Cummins, we learn a lot more about engine development, turbo development, fuel system development, and being part of that family, we can now optimize our system to make sure overall performance is the best, emissions are the lowest for the entire engine system that's out there. But also, There's a lot of technology on these engines. All the new systems, the HLAs, the cam phasers, Type 2, Type 3 double overhead camshaft architectures. I'm really excited to see all this technology making it out into the market, see how end users accept it, see how they like the new engine brakes.
Great, thank you so much. We're going to shift into the live Q&A session next. So we'll go look at our chat, and Gabe will be happy to answer some questions. So if you have a question about anything we've talked about today, please submit it to the Q&A or the chat, and we'll do our best to address as many as we can.